All right, so I want to get started with this. This is the graph challenge I gave out on Thursday, December 16th. There's data here for Katie Whalen, who is the daughter of a friend of mine who gave birth in April of 2020. And so these data points were after she was born. She went to the doctor, so the doctor checks on the baby's health to make sure that she's growing correctly. The baby's name is Katie, and so they get weight and height data. So this is the weight data. All the points are fairly close to a line, which is pretty interesting to me. If the data was a little bit off, then the line of best fit should be something which best approximates that data. In other words, you don't have all the points above or all the points below the data. The angle or the steepness of the line should allow the data to come closest to points on that straight line, even if there's some above and some a little bit below. At any rate, we determine the slope of a graph by looking at the change in y-axis data and dividing that by the change in x-axis data. Now, you might have heard this as rise over run, which is fine, but I want you to understand it's a difference between points you choose on the graph. And then you're going to look at the difference in the data over here on the y-axis, divide that by the difference in data over here on the x-axis. So the line equations start out as y equals mx plus b, but we don't finish with that because we're not graphing y's and x's, we're graphing weight and age. So in this case, the y stands for the y-axis variable. It could also be data. M is the slope of the graph. The x-axis variable here is age, and 8 pounds is the y-intercept. That, in this case for Katie, was her birth weight. The meaning of slope and how to get slope, we would do something like this. We choose 2 points on the graph. I chose 1 and 2 here. I like to choose 2 later on than 1. It doesn't matter as long as you do the math correctly, which is 1 and which is 2. But if you do it where 2 is higher up or later on in the graph, you tend to not have to have as many negatives, like subtracting negatives, which is difficult for some students to do. At any rate, so I've chosen this is 0.2, this is 0.1. So when I look at this to calculate it, I want the y-axis value for 0.2. Well, if I look at this over here, that's 20 pounds. The y-axis value for 0.1 is here. That's at 14 pounds, judging from my graph scale. The x-axis value for 0.2 is down here. That's at 10 months. The x-axis value for 0.1 down here is 5 months. So I have 20 minus 14 pounds in the numerator, 10 minus 5 months in the denominator. That's 6 over 5. But we reduce that to a decimal form. So that's 1.2 pounds per month. And the slope tells us the rate of change. So it tells us really the rate at which Katie was gaining weight. The y-intercept in this case is 8 pounds. And the meaning of that in this graph is that's Katie's birth weight. If we look down here, if she was born on April 15th of 2020 and now it's the middle of December 2021, she's 20 months old. So we're going to use the mathematical model, which is this. So we're essentially using weight down here. The slope we just calculated is 1.2 pounds per month, age, and then 8 pounds was her birth weight. We're going to plug that into the mathematical model. Weight is 1.2 pounds per month times her age of 20 months plus 8 pounds. And that actually would equal that's not letting me do that. That actually would equal 32 pounds. Okay, so that is her current predicted weight based on the mathematical model. She actually weighs 31 pounds. The next thing I asked you to do here was to draw a line of best fit for her brother Eddie. He was born a little early, so he had a birth weight a little lower of 6 pounds, but he gained weight at 1.5 pounds per month. So when I go back up here, I plot Eddie's starting point as 6 pounds, and if he's gaining 1.5 pounds per month, that means it's 3/4 of one of these boxes, because each of the vertical scale boxes is 2 pounds. So 3/4 of a box per month. That's a little bit annoying. So I just thought after 10 months, if he's gaining 1.5 pounds per month, he would gain 15 pounds. 6 plus 15 is 21. So after 10 months, I went up here to 21 pounds. I put another point down there, and I drew my line of best fit. This point here, where the lines cross between 7 and 8 months, or 6 and 7 months, that's where Eddie actually had the same weight at the same age as Katie did. His line is steeper, so that means he's gaining weight faster than she did, but at that particular age, they would have both been the same weight. So again, hopefully this helps, and if you weren't in class, I would encourage you to really make sure you understand how to use the slope-intercept form of a line.